been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Geometry 7.6, continuing with trigonometry, looking at sine and cosine. So we have a right triangle here. The sine of an angle, for example, angle A, is going to be equal to the opposite leg over the hypotenuse. And the cosine of an angle is going to be equal to the adjacent leg over the hypotenuse. So in this specific example, the sine of angle A is going to be equal to CB over AC. The sine of angle C is going to be equal to AB over AC. So notice that they have the same denominator. The cosine of angle A is equal to AB over AC, and the cosine of angle C is equal to CB over AC. So if you notice here, the cosine of A is the same as the sine of C. Likewise, the sine of A is the same as the cosine of C. Remember, we're only looking at sine, cosine, and tangent in relation to the acute angles in the right triangle. And so that's how you find or use sine or cosine to find side lengths or perhaps the angle. So in a problem situation, we have a right triangle here. I'm going to call this triangle ABC. So I'm just going to review the ratios of the sine and cosine. So the sine of angle A is going to be equal to 16 over 65. The cosine of angle A is going to be equal to 63 over 65. Remember that when I talk about opposite and adjacent, I'm never referring to the hypotenuse. The sine of angle B is equal to 63 over 65. So again, notice that's the cosine of A. And the cosine of B is going to be what the sine of A was, which is 16 over 65. And I could simplify those ratios, or I could put them in the calculator and get an estimate to know what those ratios would be. So now we're going to actually solve for a variable using sine or cosine. You need to decide if you're going to use sine or cosine. Now, I know two of these angles. One is 90, one is 35. Remember, I can find the third by subtracting 35 from 90, or 90 plus 35 taken away from 180. And so this third angle is going to be 55 degrees. 55 plus 35 is 90. So I do that just so that if I need to use it, or if I think that's going to be easier to use, then I have that option. So, but assuming I use the 35 degrees, I know what the opposite side is, and I also am trying to find the hypotenuse. Opposite over hypotenuse is sine. So I'm going to say that the sine of angle 35 degrees equals 11 over x. So remember, I'm going to multiply by x on both sides to get it out of the denominator. X times the sine of 35 equals 11. I'm going to divide by the sine of 35 on both sides. Remember, the sine of 35 represents a value. So x equals whatever 11 divided by sine 35 is. This comes out to be about 19.18. That's about how long the hypotenuse of that triangle is. All right, so in this problem, I'm going to see if I can use cosine instead of sine. Remember, cosine of an angle is equal to adjacent over hypotenuse. Now, if you notice here, I don't know the hypotenuse of this triangle, but I also don't know this leg. But what I could do is I could say that the hypotenuse is y, because I know the adjacent side to angle 28. So I know that the cosine of 28 is going to be equal to 30 over y. Then if I solve for the hypotenuse, I can use Pythagorean theorem to find x. So again, I'm going to multiply by y on both sides because it's in the denominator. So y times the cosine of 28, which is a value, equals 30. Then I'm going to divide by the cosine of 28 on both sides. So y is equal to about 33.977. So then I can use Pythagorean theorem, x squared plus 30 squared equals 33.977 squared. So when I square the 33.977, I get 1154.44. 30 squared is 900. Then I'm going to subtract the 900 from both sides. X squared equals 254.443. And then I need to take the square root of both sides to get my final answer, which is about 15.95. So I solved x by using cosine to start with to find my hypotenuse, and then using Pythagorean theorem to find the value that they really wanted me to find.